Yes, so today we were very happy to have David and Tim to be our speakers. So they're respectively the CTO of ICANN and Tim is the CISO of the Cheung Kong Hutchison Holding. So as well as Alban, the East Asia Regional Director of CSC Global, joining us. Okay, so the first part of this webinar would be David sharing his insights and and then we will have a panel discussion with Tim joining and Alban joining as well. So without further ado, let's have Wilson to have his, a little bit of his welcoming speech.
Okay, good morning, everybody. Thank you very much for joining us today. We are very proud and happy to host the Cybersecurity Beyond the Firewall event today. This is the first time to have a co-host webinar by ICANN, CSC, Asia, and HKIRC. We are delighted to have a CTO of ICANN, David Conrad, and Chief Information Security Officer of Cheung Kong Hutchison Holding, Mr. Tim Archer, East Asia Regional Director of CSC, Alban Guan, and CEO of Asia, Mr. Edmund Zhong, here with us today. Our topic today is cybersecurity beyond the firewall. So what is beyond the firewall? Is it the intrusion detection system or other prevention system? Actually, none of them. Today, we are going to talk about the domain name system. Domain name system is not a new thing, but it is the cornerstone of how the internet operates. Every time you try to type domain name in your internet browser, it will refer a DNS server to find a corresponding IP address for you. Although domain name system is just a small part of the internet, it ensures the best browsing experience of the user. What if the domain name system is not working or hijacked? It definitely will affect the business operation, such as website, mail server, and other internet connection. This kind of incident left bad impression to your customer and your corporate image. Regardless the size of your organization, the creation and protection of your online presence are very important, as it is your online access. If your online identity, such domain name system, got hijacked, will impact your business activity and the interconnection with your customer. In the worst scenario, it may cause data breach, resulting in financial loss and reputational damage. Over the year, the domain name industry players, such as ICANN, registrar, have committed resources to ensure the domain name system remains stable and secure. Nevertheless, internet security and safety is everybody's responsibility. Enterprise should take the necessary measure to protect the domain name from being attacked or hijacked. In the following section, our keynote speaker, David Conrad, the CTO of ICANN, and the speaker from the industry will share with us the current situation of DNS hijacking, and also how to evaluate your current security measure against this kind of attack. In conclusion, cybersecurity is collective responsibility. We, as a domain name industry player, have been keeping our own resources to keep the security of the system. I'm also looking forward to your active participation in maintaining a safe internet world. Thank you very much. Now, let's welcome our keynote speaker, David, CTO of ICANN, to share his insight with us. David, please.
Thank you very much, Wilson. And thank you everyone for allowing me to speak to you today. I'm David Conrad, ICANN's Chief Technology Officer, and going to talk to you a bit about the security of the DNS ecosystem. I guess if we could have the slides up. There we go. And next slide, please. So just to ensure everybody's sort of on the same page, I wanted to give a very, very high level overview of the DNS and the DNS ecosystem. As I'm sure everyone is aware, the DNS is frequently called the telephone book of the internet. And for the purposes of this discussion, I'll break it down into three components. There's the protocol, the namespace, and the service. Next slide, please. So the DNS protocol is quite old. It was invented in 1983, actually the same year that I started doing internet stuff myself, by Dr. Paul Makapetris. That's his picture down there on the lower right corner. Working within the Internet Engineering Task Force, which is the folks that define all the standards associated with the internet. The protocol itself was intended to be very lightweight, particularly developed around that time. You wanted something that didn't require a whole lot of CPU power or bandwidth, so it uses something known as the user datagram protocol. It has a very simple query response behavior. You ask a question to a server, or actually a series of servers, and you get back a response. And the response is one of, here's the data, or I don't know, ask to a different set of name servers, or the name or information doesn't exist, or an error occurred. Since 1983, there have been a very large number of extensions and modifications to the DNS, to the protocol and how the protocol is implemented. Usually those are aimed at improving efficiency, security, or functionality of the DNS. And even today, within the IETF, there are a number of efforts aiming at improving the DNS for sort of corner cases or various areas in which the community feels the DNS needs to be improved. Next slide, please. The namespace, I'm sure everybody's familiar with this sort of the concept of the inverted tree. The DNS, all of the names within the DNS are derived from a singly rooted hierarchical tree of labels that are separated by dots. The labels themselves can be up to 63 bytes long. And if they're being used as a host name, a site that you would go to or something that you would generally type in, they have to be only consist of letters, numbers, and a hyphen. And you've probably experienced internationalized domain names. They are also actually just letters, digits, and hyphens, but they're encoded using something called Punycode, which translates the Unicode labels into something that fits within the DNS and the hostname context. And each sort of key design requirement of the DNS in order to allow it to scale was that each branch of the domain name tree can be independently administered. So .com is administered by someone different than .ru. Example.com is administered by someone different than .com. The top of the tree is called the root, and it's administered by ICANN under the authority of the empowered community. It used to be, a long time ago, all of 3 years ago, or 4 years now, the ICANN operated the root under a contract with the US government. But there was the transition of the IANA functions, and part of that transition was to create something called the Empowered Community, which now is the body that basically has the authority to tell ICANN what to do. The first level of labels are known as the top level domains. There are 3 types of those. There's a country code top level domains, 248 of them. They're generic top-level domains, over 1,000 of those, and there's one infrastructure domain, .arpa, which long ago stood for the Advanced Research Projects Administration, the US Department of Defense body that created what became the internet. But today, actually since I believe 1996, is known as the Address Routing Parameter Area. Sort of a cute retronym that got built when the US government gave up .arpa. The ICANN community defines the policies for generic TLDs. And there's subtypes of those of dot brands or legacy TLDs versus new TLDs, sponsored TLDs. Policies associated with country code top-level domains are actually defined by the countries themselves. And you can have up to 128 labels, but nobody'd be that crazy. That's just way too much typing. Next slide, please. So the DNS service is how the protocol is implemented. It has two sides. There's the authoritative side, which publishes domain names, and the lookup side, which is how the published names are pulled down into browsers and other applications. The authoritative servers are recorded by the parent at the direction of the child. So in the case of .hk, which is operated by HKIRC, they told the INF naming function operator, ICANN, to set up a number of name servers for .hk, and we at ICANN do that essentially without any questions asked. We do some syntax and semantic checking, but if a ccTLD tells us to do something, we generally do that. In the case of gTLDs, we have contractual obligations with the gTLDs, and they have to perform, make sure their name servers meet certain SLAs, but those SLAs do not apply to the ccTLDs. The lookup side, the resolution servers, also known as resolvers, are typically operated by ISPs or enterprise network operators. However, increasingly you're beginning to see public resolvers. Google is probably the most well-known. They operate at 8.8.8.8. There's Quad 9, which 9.9.9.9. Cloudflare does 1.1.1.1. They don't have to be the same digits in between the dots, but that makes it easier to remember. There are quite a number of those, but those three are probably the most popular right now. Clients send the names they want looked up to the resolvers, and then the resolvers first ask the root name servers. The root name servers will typically provide a referral back to the top-level domain name servers. The resolver then asks the top-level domain name servers. They'll get a referral down to the second-level name servers, and that continues until you get some sort of answer. The picture on the right sort of tries to summarize that. The reality of the DNS, and part of the reason it's somewhat of a security challenge, is that there is a tremendous amount of complexity that's sort of hidden within that picture. There are things known as forwarders, which receive queries, then forward them on, stub zones, which are a limited set of names that sort of block off entire subtrees. There's split horizon DNS, so you have an internal namespace versus an external namespace. But for the purposes of this introduction, I'll keep it very simple. Next slide, please. What is the DNS ecosystem? It's all of the DNS stuff that I previously mentioned, plus the software. So there's a number of open source and commercial implementations of the DNS protocol. A set of them are there on the right. Those are, with the exception of Microsoft, all the open source ones that I can find. There's the provisioning side, which in the ICANN world has been sort of partitioned into the registry, which creates the namespace, the registrar, which sells domain names to registrants. And there are a myriad of other ecosystem participants, folks like ICANN, IETF, the resolver and network operators, root server operators, the root zone maintainer, which is the folks who actually modify the root zone at the direction of ICANN. That function is currently performed by VeriSign. There are domain resellers, DNS hosting providers. All of these folks play an important role in DNS ecosystem security. Next slide, please. So this is getting into the more interesting bits for the purposes of this talk. As Wilson mentioned, the DNS is a critical component of the internet, and the DNS ecosystem is very large. It's very complex and has a myriad of players, and those players have differing levels of competence. This results in a very large attack surface. What follows in the slides that I'm about to present are a few of the vulnerabilities and some of the mitigations for the protocol, the namespace, service provisioning, and software. Next slide, please. So DNS protocol vulnerabilities and their mitigations. So when the DNS was originally defined, security wasn't really a focus, and there was no protection against data corruption, whether it occurred accidentally, bit flips on the wire, or an attacker was trying to do bad things. That URL there provides a nice introduction to something that is known as DNS cache poisoning, which is a way attackers can insert whatever information they want in a response to a question. So basically allowing the bad guys to redirect traffic wherever they would like the traffic to go. There is a mitigation for this. Pretty early on, I think first in 1991 or so, this vulnerability was identified as a problem, and work began on a way of fixing it. And that's called the DNS security enhancements, also known as DNSSEC. And DNSSEC works by having registrants or their agents cryptographically sign the data, and then having the resolver operators look at those digital signatures and verify that the data hasn't been modified since it was signed. This allows a trust in the data regardless of its source, and it actually stops the attack that I had mentioned, the cache poisoning attack, where a bad guy goes and inserts whatever he wants into a response. Currently, about 95% of the top-level domains are DNSSEC signed. And about 25% of resolver of names being looked up are actually validated using DNSSEC signatures. 25% is lower than we'd like, but it is high enough that if someone is trying to attack using the domain name system, it can generally be detected relatively quickly. You sort of get into a situation that you get in the pandemic world, something called herd immunity, where you don't have to have everyone vaccinated. You just have to have enough that that the disease can't propagate. In the context of the DNS, it's a similar concept. You don't have to have every domain name signed or every validator validating, every resolver validating. What you do need is a sufficient number to actually detect the problem to allow people to go in and fix it. Another protocol vulnerability, which wasn't really seen that way until pretty much the Snowden disclosures, which occurred a few years ago, was this concept of query response confidentiality. The DNS as originally defined transmitted all its data and all responses in clear text. So if you're happening to be able to see that traffic, you can see all of the information, everything that's being looked up and all the responses to those lookups. That provides a surprising amount of information to an attacker because they can see the metadata. They can see which websites you're trying to connect to. For example, if you're trying to connect to a bank, then they can tailor their attack so that if they know which bank you're going to, they can dummy up a web page that looks like that bank and use other techniques to redirect you into that faked up website. The mitigation for this is known as DNS over HTTPS or DOE or DNS over TLS to encrypt the traffic. This is a little controversial, mostly due to how DOH is being deployed. It bypasses service providers, which sort of annoys the service providers. It also has the effect of bypassing like parental controls and that sort of thing within a site, which can annoy parents. So it has been a bit controversial. Next slide, please. Looking at DNS namespace vulnerabilities, there are a couple of classes of risks. One is the homoglyphs, which are one or two characters or glyphs that appear identical or at least very similar. So Amazon.com versus Amazon.com in that on that slide are actually reference very different sites. The first one is Amazon.com. The second one, if you look at the middle A, you'll see that it looks slightly different than the first A, and that's because it's actually a Cyrillic A, the written language in Russia and countries like that. So unless you're looking very closely, then you may get redirected into the wrong website. Similarly, there's gmail.com and gmail.com, and I'll leave it for people looking at the slide to figure out which character is being misrepresented in the second domain name. Typo squatting is relying on the fact that people make mistakes. Typos when you're typing something in, so Disney.com versus Dinsey.com. These typo squats are ways in which people can get redirected, similar to the case with homoglyphs. Whether these are actually vulnerabilities depends on usage and context. It's entirely possible. There is a company called Dinsey.com, and they'd probably be annoyed that people keep typing Disney when they want to go to the Dinsey.com website. Mitigations for this, unfortunately, there aren't really any good mitigations. You have to rely on users to make use of user interfaces that make the use of IDNs apparent. Most browsers kind of do this, but it sort of defeats the purpose of internationalized domain names. Internationalized domain names were created in order to make it easier for people who aren't cognizant of domain names to use labels that they're familiar with in their local scripts. If you then don't allow those to be displayed because they can be used in a homoglyph attack, then the point of IDN sort of goes away. Registries and registrars can limit what can be registered. In ICANN, there are contractual obligations that try to do this. Within CCTLDs, ICANN contracts don't apply, so that's an ongoing issue. Ultimately, end users must remain vigilant. You just have to watch where you're going. And if you see a padlock, make sure it's a green bar as opposed to a non-green bar. If it's a non-green bar, then you check to see if the certificate is actually going to the name that you want it to. It's very complicated and will undoubtedly continue to be a problem moving forward. Next slide, please. Service vulnerabilities, there are a number, redirection, changing domain name servers to point to attacker-controlled authoritative servers. This is mitigated using DNSSEC, as long as the resolvers are actually looking at names that have been DNSSEC signed. Resolver hijacking causes the DNS queries to be answered by an attacker-controlled resolver. Again, if you run a DNSSEC validating resolver, then it addresses that particular problem. But there have been cases where people are able to break into the home routers and change the configuration so that the resolver is hijacked to point to an attacker-controlled resolver. In those cases, obviously validation is not going to help you any. And of course, there's always denial of service. That one is very common these days. There are services on the internet that you can pay money and denial of service attack, their stressor or load test services. There's a couple of mitigations. The obvious one is to use a denial of service mitigation service. You could also, if you have the resources, deploy multiple servers using something called Anycast routing techniques. It's also worth noting that the DNS itself is frequently used as a denial of service vector because it has a lightweight protocol that doesn't require a connection to be established. You can spoof the return address and then use the DNS to attack whoever you'd like. Next slide, please. There's one point that I wanted to make about an implication of in the service space with hierarchical namespace. Because you have a hierarchical namespace, one of the implications is that the higher up you can compromise a name within that namespace, the more power you're able to wield. All of the subdomains and all of their subdomains are vulnerable. If, for example, you're able to compromise the com name service, something that would be an impressive feat, it would mean that every second level domain in com could be redirected to wherever you would like them to be redirected. Similarly, if you are able to compromise a second level, like Microsoft.com, then any name within the Microsoft.com domain could be redirected. There's also something called transitive trust, which means that you have an implied trust in all of the servers. So next slide, please. This is a graph of two top-level domains. The first is .eu and the second is .int. And this attempts to identify all of the machines that are impacted whenever you look up a name. So in the case of EU, it's relatively clean. Each one of those ovals in that picture represents a server. In .int, it's much worse because the namespace that is implemented in .int goes out to a whole bunch of different name servers in different domains, which means that all of the machines and all of those different domains are also a source of a way of compromising machines. A mitigation for an attack against the name servers themselves is to deploy DNSSEC. Next slide, please. And I see I'm running a bit short on time. So provisioning vulnerabilities, registrant compromise, which is an exposure of the credentials that allows the attacker to pose as the registrant. The mitigation for this would be just making sure you use good passwords, don't share passwords, normal cyber hygiene stuff, and something called registrar lock, which means you have to have an out-of-band mechanism to change information within a domain name. There's registrar compromise. The attacker breaks into the registrar. That means that all of the customers of that registrar are vulnerable. Again, good cyber hygiene would help in this, make sure all the systems the registrar is using are up to date. And there's something called registry lock, which is similar to registrar lock, except it applies one layer up. And then the registry compromise can modify any domain within all the domains administered by the registry. The mitigation here is, again, just good cyber hygiene. Next slide, please. Software vulnerabilities. The DNS is now pretty old. It has evolved over time and has gotten very complicated. There are 297 RFCs representing 5,000 pages. And implementing this is hard. And anytime there's a bug or anytime there's more code, there are more bugs. Next slide. Some topical examples, myetherwallet.com, that was a cache poisoning attack. It was a combination of a routing system. Users are redirected to a site in Russia. Only 150,000 K was stolen out of the Ether, the cryptocurrency wallets, and deposited in one that had 17 million. There were COVID-19 related attacks that used the namespace, names that looked like something similar to COVID. But only 0.5% of the domain names matching COVID-19 related names were phishing or malware. And then there's a DNS espionage attack, which went after provisioning and the namespace, was able to compromise a couple of top-level domains. For example, .gr for Greece was compromised. So all the names under Greece were vulnerable to compromise. Next slide. Just summarizing, the DNS is a very complex system and combines a set of protocols and namespace and service to provide unique services critical to the functioning of the internet. And since it's ubiquitous and critical, it becomes an excellent target. Each part of the DNS in a larger ecosystem has its own vulnerabilities. And the mitigation of those vulnerabilities requires participation of all actors within this ecosystem. And with that, I will hand it back. Thank you very much.
So thank you very much, David. My name is Alban Kwan. I'm the Regional Director of CSC. And the next session would be for David and also for for myself and and Tim Archer to be having a kind of a discussions. My plan is actually having a dialogue between Tim and David, because I think this would be a rather interesting interaction. I just like to see if Tim is back by the time. Yeah, I can see Tim. So what I want to say is that I'm hoping that I don't even need to jump in. If Tim have enough questions to facilitate dialogue, then I'll stay out of it. But if required, certainly I'll help facilitate some questions, and I also take questions from the audience as well. If any of the audience you have any questions at all, please feel free to type in the chat, and I'll help ask those questions to Tim and David as well. So well, with that, Tim, maybe I can just pass to you and see if you have any comments on questions, and especially how what David mentioned apart in the real business as well. That would be interesting things for us to know. So, Tim.
Sure. Yeah, look, thanks for having me, Alvin. And thanks for joining, David. Look, certainly very interesting discussion and very, very good summary of the highlights and the key issues. I'd be interested to know if there's any data on sort of how many businesses are using things like the registrar locks and the registry locks level of adoption, and particularly if there's any particular factors around a business that encourages them to adopt those particular technologies.
David, I think you're on mute. You're still on mute.
There we go. Sorry about that. Yeah, so we don't, within ICANN, have statistics in that space. I know that most registrars offer registrar lock as a service, in many cases a no charge service to their customers. It's relatively straightforward to offer. It has somewhat limited benefit because if the registrar itself is compromised, if the registrant's account is compromised, then they can go in pretending to be the actual real owner and turn off registrar lock. But it does prevent someone from coming in externally and trying to change those names without having a out-of-band communication with the domain owner. In the case of registry lock, it's less common because everyone implements registry, each of the registries implements the registry lock differently. Most registries do have a way of allowing their customers to say, no one, don't make any changes to my domain name unless you hear from me explicitly. Don't allow the registrar to change without contacting me. But in many cases, it depends on the size of the registry, whether or not that's something that the registry will make commonly available or only to sort of their high value customers. So it's an area that, particularly as a result of the attacks known as DNS espionage or Sea Turtle, is increasingly an area that we're trying to encourage registries and registrars to implement. There are business reasons why folks don't implement them, but they would be very helpful if they could be implemented.
Do you think things like registrar locks and registry locks are enough in terms of controls around DNS, or do you think there's more that we should do?
I think there's always more that can be done. In many cases, one of the things that I've been pushing for as much as I can is to try to have everyone do multi-factor authentication, preferably with a time-based system as opposed to SMS, but even SMS would be helpful. One of the things that we've run into quite frequently is a relatively high level of ignorance about how the DNS works, how the DNS system, particularly the hierarchical namespace, the implications of the hierarchical namespace can impact security, and what happens if a name server gets compromised, what can happen when a name server gets compromised. So these are areas that we've been trying to promote. ICANN has, my boss, the CEO, has in his goals this year, the creation of something called the DNS Security Facilitation Initiative. And the intent of that is to collect best practices, information, tools, techniques for the DNS community in the entire ecosystem to sort of improve the security of the DNS.
Elvin, did you have some questions you wanted to ask?
Yeah, well, there is indeed questions, but I actually want to give you some stats as well, Tim. It just happens that we have conducted a study a couple of months ago on the Forbes 2000 and the security level of the Forbes 2000 companies, and one of the factors that we look at is indeed registry lock adaptation. From where we can see, the US adaptation of registry lock among the Forbes 2000 is about 30% in comparison to 6% in Hong Kong. So Hong Kong is pretty low. I think you guys are one of them, but not a lot of other people did that yet. In terms of US financial sector, about 50% actually implemented registry lock compared to 0% in Hong Kong. So I think we as a whole are falling slightly behind. But let me also ask a questions from the audience as well. Alex asked a question, how to build a secure DNS server. Any comment from both of you?
So
David, do you want to go?
Yeah, sure. DNS servers, as I mentioned in my slides, have become very complicated. They're very large pieces of software these days. I think Bind, which is one of the more common name servers, is probably upwards of around 1 million lines of code now. The first, obviously, get the name server software from a reputable source. Unfortunately, there aren't any provably secure name servers out there. There was an effort, it was funded by the US Air Force Academy to develop something called Ironside, which was a provably correct name server implementation, but it seems to have died on the vine. It was written in a language called Ada, which probably very few people know these days. Getting a secure operating system, locking down all the services so that you have a minimum number of services, using software from the reputable sources, validating the signatures of that software. So basically just normal things that you do to create a secure name server or create a secure service, regardless of what the software is, would probably be applicable. And make sure that it's updated frequently.
Yeah, I was going to say, just adding that patching is probably quite important.
Yes.
Things like, depending on the service, things like endpoint detection response and malware prevention, and access control as well. So making sure you've got strong access control, two-factor authentication, or certificates, limiting access to services, which is, I think, what David touched on. I think the other thing to consider too is if you're building a DNS server, whether it's best to build it yourself or whether there's someone who can build a more secure DNS server for you and outsource it as well. So that's something that should be considered as part of your decision to build or purchase. Yeah,
that's actually a question that I want to ask you both as well, because David, in your presentation, you also mentioned about the Anycast network as one of the more secure architecture, and as you know, the DDoS, especially DDoS on the DNS level, can easily reach terabit per second of attack. Is that practical to even think about building a secure DNS server by yourself? In this age, what do you think?
So it's an interesting question. You know, if you have the resources to deploy your own Anycast cloud, on the one hand, it's actually getting cheaper these days because VPSs are getting cheap, and you just throw your machines out there into virtual machines all over the planet. But realistically, you're never going to be able to create a system as secure or as resilient as folks like Google or Cloudflare, those guys. And the costs of providing that service can be quite high. ICANN runs one of the 13 root servers. And we spend, in the way we've deployed it, we probably spend about $2.5 to $3 million US a year in order to ensure that our root server is stable and is resilient in the face of massive denial of service attacks. At a certain point, you have to look at what your company does, whether or not running a DNS server is core to your company, and whether it makes more sense to outsource.
Tim, do you see the same, or do you have any comment?
Yeah, look, I don't really have much further to add. I think it really comes down to business case and risk appetite, and I guess likely risk of attack as well, and find the right balance for the particular organisation. I don't think there's a one-size-fits-all solution.
Great. So on the audience, there's another question about the adaptation of DNSSEC. So they want to know, anything you want to suggest to a company before they start on enabling DNSSEC. But to that question, I actually want to ask a further question as well. So ICANN actually pushes the community globally to adapt something like DNSSEC or IPv6 without much success. To be quite frank, we've been pushing it for I don't even know how many years. So why do you think we're not successful? And is DNSSEC any different from the likes of IPv6 that company really should pay more attention to it?
So to speak to DNSSEC, the challenges, there have been a number of challenges in how to get it deployed. One has been the problem that it solved, in particularly protecting against cache poisoning, was not an attack that was very common. There were, until very recently, very few documented attacks that cache poisoning protections that DNSSEC can provide would have prevented. MyEther wallet was one of the first, and that had obviously, if you're going to be spending money, you want to actually address the thing. Sorry about that. You want to address the attacks that you're facing as opposed to the theoretical attacks. The other problem has been that implementing DNSSEC was incredibly hard. It was to deploy it on your name servers was something that very few mortals would dare to take on. And it also, if you did it wrong, the impact was pretty bad. You would basically disappear from the internet for anyone who actually did validation. And the third problem was that no one was doing validation. Turning on, it was sort of a chicken or egg problem, and which is actually similar to the problem with IPv6. DNSSEC doesn't have value unless people are validating, but turning on validation doesn't get you anything unless you actually DNSSEC sign your zones. So we've at ICANN recently transitioned or sort of pivoted to try to encourage people to turn on validation, because it's a lot easier, a lot less risky in terms of if you make a mistake, nothing significantly bad will happen, and it's easy to fix. And to try to increase the value for folks who are actually signing their zones. As I mentioned in my slides, and I also should say that we also contractually require the GTLDs to sign their zones. So that's caused, all of these are attempting to break out of the chicken or egg problem. In the case of V6, it's a sort of a similar problem. There are not a lot of sites that you can't get to with V4, which means that there's no real incentive to migrate away from v4. And since there's no incentive for people to migrate away from v4, there's not a whole lot of incentive, or there hasn't been until relatively recently, a lot of incentive to move to v6. That's changing a bit with the run out of IPv4. Now the spot price for IPv4 addresses on the market is around $22 to $25 US per IPv4 address. And that's resulting in some encouragement to deploy v6 because v6 is still essentially free. You just need to become an RIR member. So I hope that answers the question.
Yeah. Tim, do you have any comments on that?
No, look, I think David's pretty much covered everything that I was going to say. Really, it comes down to the level of effort required to actually, and resources required to actually make these changes versus what's the benefits gained. And obviously, David sort of highlighted some of these technologies. There's technical limitations that prevent adoption. So,
yeah, I want to ask Tim a question. Actually, I know Tim, you have to go soon because of another meeting. But I think in terms of what David mentioned in his presentation, what do you think? I think a fair bit of what David mentioned may not be adapted by the Hong Kong business community at the moment. What do you think, from a business perspective, the biggest concern? Is there a money concern? Is there a technical concern? Why do you think these are not being addressed by a lot of the enterprises?
I think it's a lack of understanding or acceptance of the risk. I think we have a tendency to take on a bit more risk than probably what the Western world does. And that's probably why the US is a bit more risk adverse. Whereas I think in Hong Kong, we tend to take on a bit more risk, which is why we're less concerned about these issues and less willing to invest in fixing them.
Do you think this is coming from a real comfort of the risk not applicable, or is it just a lack of knowledge? Is that what do you think would that be?
Look, I think probably it's a lack of cyber maturity as a whole and technology maturity as a whole in Hong Kong. I think we've probably fallen a little bit behind where some other parts of the world are in terms of our understanding of these technologies. And I think as we mature, it'll become more important.
Great, thank you. I actually want to ask this to David as well. Like, Hong Kong is an international hub in Asia, an important one. And in your deck, you also mentioned the DNS espionage attack by the Sea Turtle Group. That's a state-sponsored attack, a massive undertaking actually. And certainly Hong Kong is kind of catching a political epicenter at the moment. So what would be your advice in terms of for Hong Kong business community to improve their overall cyber healthiness, especially related to the internet related cybersecurity that you mentioned before?
So back when the DNS espionage Sea Turtle attacks were occurring, we actually did an advisory to our community, basically suggesting a set of steps that they could take to basically harden their systems. And a lot of it really boils down to basic cyber hygiene, making sure your systems are patched and updated, making sure that if you can, move to multi-factor authentication, that sort of thing. I think, unfortunately, the reality is that if a state-based actor is targeting you, your chances of defending against that attack are minimal. The best you can probably hope for is that you get notification that the attack has occurred, that you've been compromised, so you can take appropriate actions to deal with that. Notify your customers, notify, in the case of a registry or registrar, make sure that you have sufficient notification, sufficient monitoring to ensure that when name servers magically change, that you at least are aware of those changes as they occur or soon after they occur. there have been a number of efforts in places like the UN and elsewhere to define rules of cyber norms, right? The mechanisms to try to discourage state-based actors from going against underlying infrastructure, such as the DNS. And there have been a number of advisory groups that have come up with, the concept of the public core of the internet, of which the root and tuple domains are typically placed. Unfortunately, those don't seem to get a lot of traction because cyber attacks, particularly state-based cyber attacks, are very hard to defend against and also very hard to attribute. So it's hard to figure out who's actually attacking you. In the case of the Sea Turtle and DNS espionage attacks, there are some suspicions about who attacked, but there is no concrete proof. No one's admitted to it, and it's unlikely they ever will. So the best that I can recommend these days is to just try to tighten things down as much as you can and ensure that you have monitoring and observation of your critical systems sufficient and out of band sufficient that if an attacker is able to compromise, that you're at least aware of it.
Great, thank you very much. I think we are almost time. So before I pass on to Edmund for closing, Tim, do you have any last comments you want to make?
No, just thank you for the session. Obviously, hopefully everyone found it insightful, and thank you, David, and thank you, Alvin, for your parts and for attending.
All right, thank you very much. Edmund, I'll pass on to you.
All right, I'm
Yep.
unmuted now. Sorry
Yep.
about that. Thank you, Albin, and actually thank you, Wilson, David, and Tim for the wonderful presentation. My job in some ways is just to wrap up, but I guess I will add a little bit of my thoughts to the topic as well. As David started the discussion with the presentation and the very interesting and broad question of how to have a secure DNS, I think the DNS ecosystem, as David mentioned, is a multifaceted thing. It's not just technical. We focus quite a bit on the technical aspects of it today, but aside from that, there is also the policy aspect, as David slightly touched on at ICANN and at other places, as well as administrative aspect and how a company or an organization strategically approaches the management of DNS and your domain names. So the DNS is one part of it, which is probably more on the technical side. We have the DNSSEC and so on. And we touched a lot today on the software part of it as well. But they're just adding a point that I personally am keen about is for all types of technology, actually, a diversity of software and a diversity of platform helps increase the resilience and redundancy. Because if one kind of software fails or one platform fails, not all your eggs are in one basket. So that's something that I think the community can think about. Likewise, actually, in the administrative part, the selection of registrars, where you go buy your domain names, and the features between the registrars. Are you going to put all your domain names into one registrar or not? Those are decisions that are useful and important to think through. Similarly, the selection of registry, are you going to use .hk all along, or .asia or .com or whichever? How do you select and maybe consider having a portfolio of domain names for your front end and your back end? Those are aspects that should really think through in terms of a strategic plan for how you manage your DNS, because it's not just about the technical back end. It is also about the front end, where how you talk to your customers and how you interact with your with consumers. So at the end of the day, it's a big part of distribution of risk that I want to add, I guess, on to what David and Tim and others have said earlier. And I want to end with this this part, which is be above and beyond the technical aspect and what you can control administratively, personally. And I think, you know, this group that is gathered here as co-hosts for the event really wants to push forward the concept of participating in the global, what is called the global internet governance ecosystem. We talked about the DNS ecosystem, but related to that, a lot of it is what is called the internet governance ecosystem. And there we talk about the policies and the protocols as well. Both both ICANN and what's called IETF, which is the Internet Engineering Task Force, are aspects of the internet governance ecosystem. David touched on it just gently about there have actually been discussions about, you know, making a part of the internet as identifying it as a core infrastructure, even in times of, for example, war times kind of protection, like you're not supposed to bomb hospitals, you're not supposed to bomb schools. At the same time, you're not supposed to bomb certain, you know, attack certain DNS infrastructure and so on, as bringing it up to that kind of level. But of course, for the normal company, for the normal organizations, other types of aspects like the registry lock that we talked about, like the policies that registries and registrars put in place, those are actually discussed actively at the at ICANN and the ICANN community. And the interesting thing about ICANN and many of the internet governance organizations is that it is open. They're open and they welcome participation from anyone around the world. And it takes a what is called a multi-stakeholder approach. So unlike the UN, or, you know, unlike the WHO, where the governments are in the driver's seat, in fact, things at ICANN and other internet governance organizations, often you can participate directly and your voice can be heard. But even though it's open, if you don't participate, obviously then your voice cannot be heard. And in reality, the participation from Hong Kong and Asia has been traditionally weak, and is still this weak. And so I guess I will close here in saying that as organizers from .Asia, from CSC, from .HK, and Internet Society Hong Kong, we see that this as a beginning of a journey. And in fact, this was a somewhat of a compromise because of COVID. We were planning to have an in-person meeting with David joining us, flying here to Hong Kong. So hopefully in the next iteration, we will actually be able to do that. But I will leave with this note in saying that besides setting up your technical and your administrative part with secure technology and secure approach, the overall, the larger context of policies for the registries, for the registrars, and global policies are as important, because we in the internet, and in fact, as we now know with the pandemic, we live in an interdependent world, and your participation and your voice in all these policies are going to matter, and we want to see you there. So do follow up with us from .Asia or CSC or .HK and ISOC Hong Kong. Come to check out our website and sign up our mailing list, or join as members so that we can keep in touch and make the internet safer in many ways, because with the interdependence concept, just setting yourself up as secure is not enough. The entire ecosystem, including the policies, including the technology part of it, needs to be secure before we can have a fully secure and safe internet. So with that, thank you for joining us. I don't know whether I should pass it back to Albin or Stacy, But thank you everyone for joining. Albin, did you want to close?
That's it. Thank you very much. Thank you everyone for participation. Thank you. Thank you, David. Bye-bye.
See you guys.